We are very grateful to the BBVA Foundation for this prestigious award. As my colleague Dave Patterson has explained, the large performance advantages offered by the RISC approach were surprising. Although we had qualitative explanations for these performance gains, we did not have a solid quantitative explanation of what was happening. Thus, although many of our academic colleagues believed our results, industry was much more hesitant, which was one of the key motivations behind my efforts to commercialize the research by co-founding MIPS Computer Systems. Unfortunately, the lack of a solid quantitative explanation also made it hard for the young company to persuade customers of the advantages of RISC, as well as their durability. As I struggled with this dilemma, I decided to try to break down the time needed to execute a program into the product of the number of instructions required, the number of clock cycles per instruction, called CPI, and the length of each clock cycle. While the last of these factors is largely a function of the technology, the number of instructions depends on the instruction set architecture, while the clock cycles per instruction depends on the effectiveness in implementing the instructions, which of course also depends on the instruction set architecture. The key insight is that the RISC approach sacrificed a small increase in instruction count, typically 1.2 to 1.5 times, for a large reduction in CPI, typically 3 to 6 times. A landmark paper analyzing the performance of the DEC VAX 11780, then the #1 selling mini computer in the world, showed that it had a CPI of 10, more than 6 times that of the early commercial RISC microprocessors. Overall, the RISC microprocessors offered a performance advantage of 3 to 5 times, while also requiring less hardware. Numerous papers since then have confirmed these advantages. As I prepared to return to Stanford at the end of my leave at MIPS Computers, I was puzzled. Why had we not seen these insights earlier? And how had the commercial architectures gone so far astray? I realized that both the way we taught computer architecture and the way we evaluated instruction sets was flawed. We taught computer architecture as a survey course and focused on comparing abstract analyses of instruction sets. And we often evaluated those instructions by abstract metrics. How many different instructions? How many addressing modes? And sometimes code size. What about implementation and performance? What mattered was how fast programs could run, not these abstract metrics. I talked to Dave Patterson and found that he was equally dismayed about the state of the field and how we were teaching computer architecture. Maybe we should try to write a book to try to change how the field was taught and how researchers and engineers thought about building computers. That was the beginning of our long collaboration. We intended our book to reshape the way the field was taught and structured, to bring a scientific approach to the field, just as Don Knuth's famous textbooks, The Art of Computer Programming, had for programming and algorithms some 20 years earlier. Thus the name of our text, Computer Architecture, a Quantitative Approach. The CPU performance equation became the foundation used to analyze both instruction sets and implementation approaches. We followed the quantitative approach throughout the book. For example, we introduced average memory access time rather than just miss rate as a key metric for analyzing a memory system. Starting with a rough set of lecture notes, which we used in our courses in the fall of 1989, and taking advantage of our sabbaticals in the spring of 1989, we completed a beta version that was used in the fall. Real-time feedback from more than a dozen professors who taught with the beta version and over 100 other researchers and engineers enabled us to finish a draft by December. The book was well received and widely adopted, selling almost 10,000 copies in the first year, surpassing our publisher's lifetime estimates in its very first year. Surprisingly, as many copies were sold to practicing engineers as to students. In his preface, our renowned colleague Gordon Bell said, The authors have gone beyond the contributions of Thomas to calculus and Samuelson to economics. They have provided the definitive text and reference for computer architecture and design. Happily for us, he was prescient. A number of translations were started soon after, and the book is now available in more than a dozen languages and used around the world. Despite 6 editions and more than 30 years, we still have a great working relationship. And while those fundamental performance equations are still there, 90% of the material in the 6th edition did not appear in the 1st edition. We went on to write an introductory undergraduate version called Computer Organization and Design, the hardware-software interface. Although we had hoped that someone else would write a great undergraduate text in the same spirit as our first book, no one did. Happily, the undergraduate text enables us to reach an even larger audience. It's in its 5th edition, and together, more than 1 million students around the world have learned from our books. Helping students around the world learn from our field through our books has been incredibly rewarding. Many, many times, most recently just this week, I had a student come up to me and say, "Are you the John Hennessy?" When I reply yes, they exclaim, "You helped me learn about computer architecture, or pass a tough course, or get excited about the field." This brings me to why the BBVA Foundations of Knowledge Award is so meaningful to Dave and I. First, it celebrates the early risky approach we took in our research. The risk ideas were both counterintuitive and controversial. It is unclear, even today, whether the ideas would have gotten traction if only one team had discovered them. The award also celebrates not only those insights, but also the importance of research that rethinks problems when the parameters change, and a willingness to persevere when some people think you are crazy. Equally importantly, the BBVA Award recognizes the fruits of our 30-year partnership to change the way students are taught and engineers design computers. Today, it's hard to find someone working in our field that has not had the experience of using Hennessy and Patterson, or Patterson and Hennessy. And this award celebrates in a very special way that global impact we have had. My sincere thanks to the BBVA Foundation Selection Committee, to my good friend Dave Patterson, and to our colleagues at Stanford and Berkeley, to my family and to our students around the world that have graciously journeyed into the field of computer architecture with us.